Hi and welcome to the Math Walkthrough on Cambridge IGCSE 2020 to 2022 Specimen Paper 2 58002. Question 2. The mass of a carbon atom is 2 times 10 to the power of minus 27 grams. How many carbon atoms are there in 6 grams of carbon? This would be 6 divided by 2 times 10 to the power of minus 27. Next, write the following in order of size, largest first. By identifying each of the values in decimal, it is easy to arrange them in the required order. Question 4. Express 0.123 as a fraction in its simplest form. This would be 123 over 1000 minus 1. And it's in its simplified form, 41 over 333. Question 8. This is a sketch of two lines P and Q. The two lines P and Q are perpendicular. The equation of line P is y equals 2x. Line Q passes through the point 0 and 10. Work out the equation of line Q. Line Q being perpendicular makes it y equals minus half x plus c. By inserting the known values of x equals 0 and y equals 10, we could solve for c. Hence, line Q is y equals minus half x plus 10. Question 9. The point A lies on the circle center O of radius 5 cm. Using a straight edge and compasses only, construct the perpendicular bisector of the line OA. The required perpendicular bisector is as shown on the diagram. Next, the perpendicular bisector meets the circle at the points C and D. Measure and write down the size of the angle AOD. The protractor should show this as being 60 degrees. Question 10. In a flu epidemic, 45% of people have a sore throat. If a person has a sore throat, the probability of not having flu is 0.4. If a person does not have a sore throat, the probability of having flu is 0.2. Calculate the probability that a person chosen at random has flu. Start by completing the unfilled branches, knowing that branches add up to 1. The required probability is the probability of one having a sore throat with flu, and when one does not have a sore throat with flu. This is the summation of 0.45 times 0.6 plus 0.55 times 0.2. Question 11. Work out the given matrix. In doing the math, the 4x4 matrix should have the numbers 8, 5, 20, and 13. Next, work out the second metric. The inverse calculation should end up with a 4x4 matrix having the numbers 1.5, minus 0.5, minus 2, and 1. Question 13. A and B have position vectors A and B relative to the origin O. C is the midpoint of AB and B is the midpoint of AD. Find in terms of A and B in their simplest form the position of vector C. Vector C is equal to half of A plus B. Next, find the vector CD. With CD being CO plus OE plus ED. We could solve for CD being 3 over 2 of B minus A. Question 14. Find T when G is 9.8 and L is 2. The math should get us to 2.84. Next, make G the subject of the formula. This rearrangement will get G to be equal to 4 pi square L over T square. A container ship traveled at 14 km per hour for 8 hours and then slowed down to 9 km per hour over a period of 30 minutes. It traveled at this speed for another 4 hours and then slowed to a stop over 30 minutes. The speed time graph shows this voyage. Calculate the total distance traveled by the ship. The required total distance is the area below the line. It is easiest to demarcate this into two areas, one above the red dotted line and one below the red dotted line. By summing these two areas, you arrive at the answer of 156 kilometers. Next, calculate the average speed of the ship for the whole voyage. The required average speed is total distance divided by total time. Question 16. The mass of a radioactive substance is decreasing by 10% a year. The mass, m grams, after t years is given by the formula. Complete this table. By inserting the appropriate values of t into the formula, we could derive m as being 500, 405, 364.5, and 295 respectively. Next, draw the graph of the stated equation. This would be merely plotting the coordinates on the given table and adjoining each of those plots with a line. Next, use your graph to estimate after how long the mass will be 350 grams. This would be the x value for a point on the line where its y is 350. Next, when will the mass of the radioactive substance be 0 grams? It being a portion of what remains, it should never ever get to 0. Question 17. Work out the function of Fg1. The math should take us to half. Next, find the inverse of h. By letting y equal to the function of hx and making x the subject in the form of y, the inverse function of x will take this form. Next, solve the equation gx equals -2. By rearranging the equation and making it into a factor, we could solve for x being equal to 1 and 2. Question 18. The first 4 terms of the sequence are as given. The nth term is given by the stated equation. Work out the value of T23. The required value can be obtained by making n 23. Next, a new sequence is formed as follows. Find the values of u1 and u2. By doing the maths, it should get us to 4 and 9 respectively. Next, write down a formula for the nth term of un. The first method is by observation where u1 is 2 square, u2 being 3 square, and u3 being 4 square, thus making it obvious that un is equals to n plus 1 square. Second method involves expressing un as its t and further expressing this as in n's. You would expand, then simplify to arrive at this being n squared plus 2n plus 1, which incidentally matches up to n plus 1 square. Question 18c. The first 4 terms of another sequence are as stated. By comparing this sequence with the one in part A, find a formula for the nth term Vn. From the observed pattern, Vn is equals to 2 to the power of 2 Tn, and leading to this being the product of 2n with n plus 1 with 2n plus 1 divided by 3. We have reached the end of this walkthrough. Do be on the lookout of our other walkthroughs if you have found this beneficial.